On to day 3, we'll take a picture after Laura. Oh, Laura just did. Laura can go.
Okay. So this morning I'm going to do basically a condensed version of the pre-processing that Abby showed yesterday. So you guys should all be experts by now, and this will be a breeze, right? I'm just gonna walk through it so you guys can just sit back and observe. And if there's any questions that came up yesterday during pre-processing, hopefully this addresses it. If not, there should be like a Q&A session at the end, where you can just ask about either stuff I've talked about today or the things that Abby talked about yesterday or nextPYP in general.
So maybe we need to clarify that you guys will not be able to follow what she's doing because the way the resources are set up on the sessions, we have no control on how much resources each of you can use. So that could the system. So you can
Specifically for sessions, I guess an example would be if you and some collaborators are working on the same data set or same structure, then everyone that's part of a group will be able to read your sessions, but like only you should be able to write to your sessions. So in this case, I believe the group is called workshop. Okay. So now I'm going to go to the raw data tab. Very much like yesterday for the data, it's in the same location, 10164, and then I'm just going to wildcard for all the TIFF files. So star.tiff, click the filter button. I see there's 100 odd files. I choose the file pattern. There's no gain reference, again, like yesterday. So the next tab I'm going to go to is microscope parameters. Here, it's the same as yesterday. You'll see a lot of it is the same as yesterday. So 1.35 angstroms per pixel, and then the acceleration voltage is also 300, and the tilt axis angle is going to be 85.3. So now I'm going to go to the sessions tab. So this is kind of where it's a bit different from pre-processing. So let's say you're sitting at the microscope, you're streaming your data as it's coming in. The issue when data is like coming in on the fly is that you might not necessarily, the computer might not know what constitutes a tilt series. So this is where we do some of that, like telling the program how many images are in a tilt series, what it should do with these images to get from the microscope to your computer for processing. So all that being said, the first number I'm going to change is this number of tilts field to 41, because this data is gathered, minus 60 to plus 60 in 3-degree increments. So that's, I believe that's 41 images. This basically tells nextPYP that once I've gathered 41 images, that bundle constitutes a tilt series, and then I can send it to nextPYP for processing. And then the other field that I'm going to change here is this one called raw data transfer. So maybe I won't change it. I'll just kind of describe what the different options are. So you'll see in the drop-down list, there's 3. There's move, copy, and link. I'm going to leave it as link for today because it's no change. But what the other options mean is, so move will essentially take your data from wherever it's stored on the microscope and then send it. You can think of it as sending it to whatever like machine is running nextPYP, be it your cluster, your local machine, whatever. So in this case, the data will only exist on like your local machine. It won't exist on the microscope. And this is typically what we want to do with the data on the microscope, because as you might imagine, like your cluster, your network will have probably more storage than whatever your microscope is hooked up to. So you don't want to like throttle your storage at the microscope level. You can like afford to keep it on your computer. Copy will have the data exist in both locations, so it'll both be at the microscope and on your local computer. And then link will kind of make a symbolic link, or like it'll just be like a reference to the original data on your microscope. One caveat is that if you do choose move and then later on you want to delete the session, your data will also be gone. But there's like if you go to do that, there'll be a pop-up that shows like, warning, doing this will delete all your data. So, you know, if you want to delete your data, proceed accordingly. Otherwise, just be mindful of that. So I'm gonna keep this as link. Scrolling down.
Bigger,
Sorry,
can you make the font bigger?
is
This one.
that better?
Yeah.
Okay. So next tab will be CTF determination, and again, like yesterday, we'll set the max resolution to be 5 angstroms. Skipping ahead to virion detection, again, like yesterday, we're gonna be using the kind of geometrically constrained picking of our spike proteins. So the first thing we're gonna pick is the virus itself, which has a radius of 500 angstroms. And then here we'll set the virion detection method to auto, which is essentially just gonna find anything that's circular in shape with a radius this big. So we can keep all of these parameters the same, but we know that there are spike proteins on our virus membrane, so we'll change the spike detection method to uniform and change this equatorial band to be 800 angstroms like we did yesterday. So almost done. The last thing that we're gonna, or the second to last thing, is the particle detection tab. Again, like Abby said, this is just kind of for displaying the picked spike proteins in this case. So we'll keep this as none, but we'll change the radius to be 50 so that they show up. And then the last thing that I will be changing is the resources. So in sessions, unlike in a project, because you'll most likely be running this at the microscope and using it to get the first like initial quality assessment of your data, you can understand it's important to get the result as fast as you can, right? Because if you mess up like setting up the microscope or like you mess up your sample, you want that information sooner rather than later so you can like readjust things as needed. So one of the ways that we control the speed at which results get to you is through these resources, and that's also partly why you guys can't run this right now. So basically at a very high level, what you want to do is set as many resources, in this case, as many threads as you have images in your tilt series. That way, as your images come in, you can essentially process them all in parallel. So if I have 41 images coming in, I launch 41 jobs, and they all, in theory, run at the same time, and they all finish at the same time, so I get my results as fast as I can. That's kind of like, I guess, the dogma behind how you set the resources. Of course, if you don't have 41 like the resources to do one image at a time, then like obviously you're going to be maxed out at whatever the max limit of your machine is. So I'll change this to 41. And then a good rule of thumb is the memory that we allocate is generally 4 times the number of threads. So in this case, if I allocate 41 threads, 4 times 41 would put me at 164. And everything else can kind of be kept the same. So I'm going to click save now, which will take me to this operations tab. And I'll click start if there aren't any questions. Okay. So I'll click start to kind of explain what is on this page and when things are running as they happen. Oh.
I think this is great.
Okay.
Yeah.
Maybe let's go ahead and explain the components.
Okay, so I guess kind of under the hood, what is happening in the sessions is, so when you're acquiring data, you can in theory be there for like, I don't know, 30 minutes to 5 days, right? So you want, within that time, you don't want your data acquisition to stop before you're actually done gathering your data. So the way that we kind of keep this like continual job running, and you can like define how long you want your job to run based on how long you expect to be sitting at the microscope, is through these first 2 daemons for tomography. So a daemon is kind of just like a long running job. You can think of it that way. The first 2 are going to be used in tomography. The last one, 2D classification, is only available in single particle analysis. But basically the idea is you have these 2 jobs and you only need to start really the first one. So what will happen is it's kind of like a cascade procedure where file transfer, when it's done, will launch data preprocessing. And then if you're doing single particle, when data preprocessing is done, it'll launch 2D classification. When I click start, obviously the status will finish, or the status will change to running. When it's done running, you'll see the next one will start, say, running. They don't ever say like done unless you kill the job. I guess it's just something to watch out for. When the data preprocessing job first launches, what'll happen is, because we told the program that 41 images constitute a tilt series, it'll wait until 41 images have been, in our case, linked over, or, you know, yes.
Start again.
Do I need to refresh?
Yeah.
Ah, okay. Waiting to start. That's better than. So it'll take a bit to hopefully run. I guess in the meantime, we can check the logs and see if anything interesting has happened. So maybe this was a blessing in disguise. So you'll see each time you try to run something, you'll have like an option for each timestamp that you tried to run it. So if I click the most recent one, nothing will happen because I guess it's still waiting. Oh, there we go. Okay. So here it's submitting one job, which is going to be the job that links the data from, in this case, one location on storage to another location in storage. But you can imagine if you're like copying the files, it'll be copying from the microscope to your computer. And then it'll like give you some information about like how it's running, like resource allocation, stuff like that. So then scrolling down, you'll see at the very bottom here, this file transfers section of the page. We're going to be copying over like, what was it, like 123 images. So here you'll see we've done 32, 33 so far. We're transferring, 4 or 5 at a time. And because it's pretty fast, the progress bar is like moving pretty quickly to the right. But this will essentially show like each file that you're trying to copy over, the size, and then like where it is in this kind of copying process. So we've hit 49, which should give us one tilt series. So then you'll see, as we scroll back up to the data preprocessing, it's changed from not running to running. And now we have under this jobs tab, a new job Tomo session where it's going to run preprocessing on the 41 images that just came in. Other things that we could touch on here. So there's also a subsection for storage. So you can understand if data is coming in like on the fly, you might have like hundreds of gigabytes or like terabytes of data. You don't want to like run out of storage in the middle of your data collection. So the storage tab is a nice way to make sure that you don't like, run out of space before you finish collecting your data. And because we've hit another multiple of 41, I guess 82, that's going to be the second bundle of images that constitutes our second tilt series. So if we click on the logs here, then we should also see for the first the timestamp at which the first bundle of images came in for our tilt series. It'll show that we've submitted one job corresponding to whichever tilt series happened to get there first. And then we're submitting a second job for the second, whoever's in like still, second place, silver medal. And yeah, now I guess all 123 images have transferred over, so the last bundle of 41 images is here as well. So we've launched the pre-processing job for that as well. I wonder why it's waiting. Are you able to check? Yes.
When it's like taking your batch of series, sometimes on our microscope, we have to like reorder the images.
Mhm.
Cause it's like collected in a way
Right.
different. Does this like, can it tell from the metadata of like what order the images should be in?
Good question. So in the settings tab, so like yesterday when Abby walked through pre-processing, there was a part in like the frame alignments section settings where you can specify like the frame pattern. Right.
Oh,
So I
okay.
didn't touch it here because we don't change it, but essentially you've given it this like recipe to follow. So the first X number of letters is going to be your tilt series. The next X set is going to be your scan order, and then the last one is going to be, I guess, your tilt angle. So what it does is it just like pattern matches the file name to this pattern, and then reorders things in there. Yeah. Question? Yes.
So while we're running, it affect the data acquisition speed.
It like if you're at the microscope taking the images.
So because we're collecting the data, we're transferring while we're processing, right?
Right.
Does that affect the speed of the data connection?
So everything that's processing should be happening. I'm gonna like on your local machine, which is separate from all of the stuff that's happening on the
Oh, yeah,
microscope.
but processing, but it's using the storage system where the microscope store the images, right?
Right.
And it's while it's storing on that same storage, while it's also transferring to the other local machine.
Right. So if you pick the move option, you can kind of think of it as like you have a funnel and you have things coming in, right? But you also have like things coming out. So if the speed at which your images arrive at your microscope is at least kind of equal to the speed at which data gets transferred out, then it's kind of, you're at like a sort of constant rate of storage, I would say. I don't think the copying from like your microscope computer to your local computer is that intensive of an operation where you would actually see like a slowdown in terms of like performance at the microscope, if that's your question.
Even like when I collect during the data collection, if I start to transfer my data, even on the external disk, I see the slowdown. So while it's transferring the data from here to another computer where we run in the nextPYP, if that affect the data collection?
I want to say generally, like IO does incur like some like compute power, but I feel like it shouldn't be so much where you slow down things too much.
Are you transferring from the microscope to another computer, or are you having that other computer come in?
No, so all the data, like we have a K3, so all the data is stored in the K3 server, right? And then if it start to transfer from K3 to another storage, it will affect the speed of the data collection because we're using the same disk to store the image from the camera, and while it's transferring from the same disk to another state.
That might be your setup because your P3 image servers have SSDs.
Yeah.
Your 9 terabytes of SSD. That's fast as you can get for storage. So what's your pipe out? Is it copper or fiber?
Fiber.
Yeah, fiber is like, it should go at the speed of light. It should be very fast.
So it might be how you're configuring. That's something like that, where you might have this contact your, like, or sensors. Because it's actually not.
Yeah.
Not there. Maybe your fiber card is not going at the speed you think it is. Because-
Fiber card we bought from the bank, so it's like a transfer.
No, we've had issues, so technically it should be like 10 plus gig out, but sometimes it's a problem at 1 gig. Configuring. Yeah, but if you're a fiber, then that should not be an issue.
Okay. So I guess my Slurm jobs are running now, so we can see in the job subsection, each of these has changed from waiting to running, which is nice. Once the jobs finish running, you'll see the output from like the command line or whichever. Yeah, I guess from the command line will populate under logs, so it'll show kind of the same way as over here. I can see like the output information. Once like a tilt series has finished being pre-processed, you'll be able to go over to like the plots tab and have this information kind of be populated, similar to what we saw in projects yesterday. So maybe like more relevant if you're trying to get an idea of like the quality of your data. If any of these numbers looks off or is not as high as you expected, as low as you expected, then it would be like a good time to pause your data acquisition and then go and like tweak parameters there. Another thing that I guess I can highlight right now, it won't actually like mean much until like one data set has processed entirely. But you'll see in the tilt series tab, there's this like nice option on the right called watch. So what this essentially does is, like if you're sitting at the microscope, you have data coming in on the fly, watch will always keep you the most up to date with the most recently processed tilt series. So let's say that I'm on this tab and the first tilt series has finished processing and I'm looking at that data. And then while I'm looking at the data, all of a sudden the next one comes in. So watch will automatically take me from like tilt series 1 of 3 to tilt series 2 of 3. And then when tilt series number 3 finishes, then it'll take me from tilt series 2 to tilt series 3. If you don't want to like, I don't know, have your page be like all shaken up and you're like very concentrated on tilt series 1, then you can unclick watch and it'll just keep you on whichever tilt series you're on. So that was kind of nice timing. I guess the first tilt series finished processing, so TS43. You'll see that the tilt series tab is very similar to what you see in projects. So for the tilt subcategory, you'll have your drift per tilt, where let's actually be able to see all these images. Where if you like kind of hover over each of these bars, you'll get a stop motion picture of your of the alignment of your tilt series. Or sorry, the alignment of your frames, I guess. And then if you go to the alignment tab, you'll also be able to play a nice movie to double check that this case aligning with gold fiducials has worked. Right, it's all review, right? And then you go to CTF and you can also check to make sure that your power spectra and stuff looks nice. Both 2D and 1D. And finally, you'll be able to actually see the slices of your tomogram with the particles that have been picked. So in this case, with both the virion and the spikes on the virion. So basically the idea is in the sessions, you'll be able to go from your raw data to like picked particles in like, I don't know, 20 minutes. Give or take, yes.
So in this case, by spikes, you mean caps and hexamers?
Yes, image, yeah. Yep, so you'll see in this one, there's 9 auto variants, which we can show if we deselect, if we uncheck this option. So here's the 9. If you play, like moving through the slices in your tomogram, you'll see them hop in and out in the Z direction. And, oh, yep, so there we just saw watch in action. So as I was looking at, I guess, tilt series, the first one that came in, the third one finished processing. So now I'm on the last one, which has 11 auto variants, and then I can unselect that, reselect the 5,000-ish spikes that were detected, and then have that show up as I play. Okay. So any questions on this tab? It should be hopefully review from what we saw yesterday. Yes.
I'm just wondering, so things like aligning by credentials, was that something in the settings you
Yeah.
had beforehand?
Yeah.
So could you do like hash tracking or like that if you wanted?
Yeah.
Okay.
Yeah. So unblur, I guess, is frame alignment for. So this is frame alignment. Tilt series alignment. You have like iMod credentials or iMod path tracking.
Gotcha, okay.
RTOMO and stuff like that.
So building off that, say you reprocess 3D tomograms and realize you need to change some of these,
Mhm.
these settings, how would you apply that?
It's almost like I planted your question. That's what I'm gonna do next. So you'll see in the controls setting, you'll have, so we played around with start, we played around with logs. I'm gonna quickly explain what stop and cancel are, and then I will answer your question. So stop is basically if I want to like stop this one job. So let's say I am tired of file transfer running, I want to stop it. I can click stop. I won't do it now, but when I click stop, the status will change from running to not running. Pretty straightforward. Cancel is kind of, you'll see it's unique in that only the top level job, so the file transfer job, which kicked everything off, has cancel. That's because cancel will essentially take the first job and all the jobs that came after it, and then cancel from like the top down. So it does kind of make sense why cancel is only available at the top level. Now to your question, I'm gonna kind of rephrase it, but it'll like give you the same answer. So let's say I'm doing particle picking and I realize, oh crap, I like messed up the size of my particles, right? So if I go into settings and I go into variant detection, let's say I was way off with this 10 voxel minimum distance between spikes. I'm gonna go and change it to 50. So like the thing on the left has changed. I'm gonna save my changes, get the nice confirmation. And then what I can do is I can click restart just for this. So restart is kind of like a smart restart. So if I mess up a parameter, it'll go in and see, well, if particle picking changed, then I will change the particle picking job and anything that comes downstream of that. So for tomography, not much comes downstream of particle picking, but if you're doing like single particle, I guess if you change particle picking, then you would also change 2D classification. So restart is like it gives you a smart way to only rerun what is necessary in the case that you change things. If like, for example, your CTF estimation parameters are way off, your like max resolution is actually much lower than 5, then you would, let's say, change from 5 angstroms to 10 angstroms, you would have to rerun CTF estimation and then redo particle picking and 2D classification if you're doing single particle. Then you can check the logs tab to see that this restart was actually like picked up, hopefully. Yeah, here we go. So you'll see we changed the particle radius. So as a result of that, the program kind of knows like what jobs needs to be rerun. And because like all of your data is now like on our local machine, it doesn't need to wait for like each one of these tilt series to transfer over to be able to rerun pre-processing. It can just kind of submit all 3 at the same time. So that's restart. Clear would be like if you messed up really bad and you want to like start from scratch, or I don't know, you just want to start from like a fresh slate, Clear will go in and like kind of start directly from frame alignment. So yeah, it's helpful if, I don't know, you like messed up, you don't know where to go back to. If you just want to say like, I'm going to scrap it all, start again, that's when you would use Clear. So you'll see now that we changed the distance between voxels, because we increased it, we expect to get much fewer particles. So once this like second round of pre-processing has finished running, we'll see hopefully like this number up top, the 12, almost 13,000 will drop to maybe like, I don't know, 10,000, something like that. But yeah, I hope that answers your question. So I guess while we were waiting for this to run, which maybe actually finished. Yeah, so I guess on like here in the tilt series tab, you'll see before this number was like maybe 5,000 spikes. Here it's been cut like over 90% to like 100, which obviously it's not good for like gathering data, but for demoing the purposes of a restart, it's a pretty obvious indicator that things changed. So the last thing that I want to touch on is kind of what else we can do with the session that's not necessarily running things. So if we go back to the sessions page, you'll see obviously like the name that we've given our session, all that nice jazz. But then there are these like 4 buttons on the left. So opening the I button will like open your session to the page that we were just on. You can also copy your session. So if you like the settings for this one, or like you're processing the same data again, then instead of like going through that process, you can just use the same settings as you had previously. Deleting will be the thing that I warned you about at the start of this of my, I guess, practical, where it will like go and remove all the metadata and potentially the data associated with your session. So if you click this, I'm not going to click yes. There is the warning that, you know, if you move your raw data, then your raw data will be gone if you choose to delete the session. And then lastly, if you click the kind of arrow, it'll show you the location on your local storage where your files are. And what we can also do with the sessions, because you kind of see how similar this is to pre-processing, we can actually leverage this to kickstart pre-processing. So the way that that works is, if I go to the table tab, I can like basically export all the stuff that I've done to go using nextPYP, but also go using other programs like rely on. You can give a name to your filter. So let's say I call it just export. I want to keep all of my tilt series that I've processed. I click on the very far right to export. So if I click that, it'll bring up some settings and that control like how I want the export job to run. It should be like a pretty lightweight job. So I can just leave everything as is. I hit export. It tells me that I can go track the progress of this in the operations tab. Let's go check that. And then you'll see now there's like under the original exports subheading that was empty. There's a job now that launched the export. If I click the eyeball, it'll show me the location to which my data has exported. So it's kind of cut off, but this is basically the folder specific to this session that we gave it. And then under there is exports, job we ran, and then kind of the unique identifier for the specific task. And then if I click the paper, it'll see like things were exported, the job finished successfully. And then I think the last thing that I have today is to show you that we can also take kind of what we've done in sessions and use that to like jumpstart our project. So if I go back to dashboard and I click create new project, I'll give it a name like importing from sessions. I click create, I click open. In this import data option, you'll see there's everything that Abby talked about yesterday, but I'm going to draw your attention to down here, tomography from session. And here is where I attempt to remember the name that I gave it. So if you search for the name of your session, in this case, workshop 10164, you can select it, click save, and then you now have this block that pops up. You can click run, start run for this block. And then what'll happen is it'll basically take all of the pre-processing, like data import pre-processing stuff that you did in sessions, pull it into here, and then you'll be able to run like particle refinement, all the stuff that Abby talked about in the second half of her practical. So you'll see it's like kind of, I guess, importing all of the metadata, all the data from your session, launching split to kind of, I don't know, bring it all over here. And then once merge finishes, you'll have all of your data here. It'll basically look like your pre-processing tab up to, so it'll be like pre-processing and then the 3 blocks that we made yesterday for particle picking. So I think that is everything that I wanted to talk about. Hopefully that was pretty clear. Hopefully it was a review from yesterday. But basically, in the sessions, it's kind of our method of, if you're collecting data at the microscope, to be able to validate the quality of your data and also see like some preliminary results from it. So you can either copy, move, or link the data from your microscope to your local machine. Once the data is all here, you'll be able to run all of your pre-processing stuff, so frame alignment, field series alignment, CTF estimation, particle picking. Particle picking, you can pick any of the methods that we have available in our project, so like size-based, geometry-based. You can also do, and I forgot to mention this, you can do neural network picking, but only with like a pre-trained model. So if you have done like some, I don't know, particle picking stuff, like maybe with MILO-PYP, or sorry, not MILO-PYP, the other neural network based picking that we have, you have the trained model for that, and you can just like upload the path to the model and it'll be able to take that and then kind of run evaluations on it. Restart, copy, clear, delete stuff. If you make changes, depending on if they're very minor or very major, you can use restart and clear accordingly. And yeah, copy, deleting, this kind of gives you some control over maintaining your sessions. And import and export, I guess we wrapped up with that. So yeah, in theory, from here, you can kind of go and do anything you want with your particles. So that's everything I had for this morning. I think now we're going to open up to questions, either on this or in general. So. Yes.
I was wondering if I have like some tomograms I already processed outside of this, like I usually use IMOD and ISONET. Is it possible to import them to try MILO-PYP, or would I want to like restart the processing from like the raw films?
So you can run MILO-PYP on the existing tomograms, but you wouldn't be able to do that from the website. So you have to install MILO-PYP separately.
Okay.
What you could do is, if you've done all your analysis in IMOD,
Yeah.
you can actually import those the metadata, and then nextPYP will actually recreate your tomograms using your existing alignments and settings.
Is that through the import data, or is that somewhere?
Yes.
From
It's
start.
the
The alignment tab pre-processing.
Yeah.
Alignment.
Okay, I don't have to do this, but
Yeah, so instead of, you can choose iMod or RTOMO, or you can also choose to import your alignments if you have them already, from iMod. And then what that will do is we'll recreate the tomograms, and then it will be already inside nextPYP, and then you'll be able to run MILO-PYP on those. And I guess if you said you run ISONET, so if you have your ISONET settings, you will have to rerun that inside nextPYP to be able to. Otherwise you won't use those tomograms.
Okay.
But to be honest, we haven't tried MILO-PYP on ISONET denoise tomogram, so I don't know how that will go. You
Yeah.
may not need it, but it's easy to just try both.
Did you usually try them on like non-denoise, or did you use like something else?
Yeah, right. Just straight like weighted back projection, probably heavily beam, but yeah. I can't imagine that ISONET is gonna make it worse, but we haven't tried it.
Okay.
Any other questions about live or not live or anything about nextPYP? So if not, so this actually concludes all the practical on nextPYP. I just want to reiterate that you have the instances until Sunday night. I know some people were asking about being able to analyze their data within this week. We could actually arrange for that depending on how big the data is. We have to upload the data to our system using Globus, and then you'll be able to see it from these instances. So that's something that we can accommodate. I'm going to be gone this afternoon, but Laura, Abby, and Jeff are going to be around the entire week. So if you have any issues, you can talk to them. And then, as I mentioned yesterday, after the course is done and you want to try to install this, or if you need assistance, you can always reach out to us on GitHub. And then that way, we'll be able to help you out and sort out any issues. I think I mentioned yesterday that 0.70, which is the version that you guys are running here, is not formally released, but we can help you get that installed and get you going. You need that help? Okay, yeah, we can say that. It should be pretty straightforward. The installation, Chef has done an amazing work at making sure that it's, as easy as possible, without having to worry about the complexity of having all these, components and so forth. So it should be pretty straightforward, but if you do run into problems, definitely reach out. And last thing, you're going to be getting a form to get us feedback on the workshop. So we will appreciate if you can fill that out sometime this week. All right, I think that's all. Very good.
Sounds good.